So in our last video, we talked about accuracy and precision and units and why they're so important. And so we want to go into more detail about the types of measurements that you'll be seeing in chemistry often. So the first one is volume. And when we talk about volume, we want to be very specific or very precise with the words that we use so that you know the correct vocabulary to expect on a quiz or a test, that sort of thing. And so when we talk about volume, volume is the amount of space an object occupies. Okay, and this is often, it is actually not often, it is always three-dimensional. Okay, so it's 3D. You have something in the X, Y, and Z plane. Okay, now the unit that we use to measure volume, there are two most common ones that you'll see. You'll see milliliters, or you might see centimeters cubed. Now, how we get centimeters cubed is if you're taking the volume of a regular shaped object, a solid, a square, a rectangle, a triangular prism, a cylinder, any of those three-dimensional shapes, a sphere, you can use standardized formulas to get them. So for example, the most common one as for volume is of a rectangle. So your volume would be your length times your width times your height. And if you're using centimeters to measure all three, you would have centimeters times your centimeters times centimeters, and your answer would give you centimeters cubed. Now, 1 milliliter is equal to 1 centimeters cubed. So they're interchangeable. It just depends on which instrument you're using as to what unit you will have. And milliliters is often used for liquids or oddly shaped solids. Okay, if it's got a weird shape, we use water displacement as a way to figure out its volume, and we will talk about that more when we discuss density in Unit 2. Now, the two instruments that we're going to use are a graduated cylinder and a beaker. That's going to be the big ways that we measure volume in chemistry. And so a graduated cylinder, it's tall and skinny, and it's got a little base that holds it up. Okay, and it has graduations on the side. Those are the little tick marks there. And with a graduated cylinder, you can often measure out to at least 1, sometimes 2 decimal places, depending on the cylinder. And so a beaker looks more like a cup. And in this cup, you often just have 4 to 6 markings. You don't have very many. And so a graduated cylinder is going to be more precise than a beaker because of let's rephrase that, because it has more graduations or tick marks. Okay, but you need to be able to know that the vocabulary word here is graduations. Okay, you can write down tick marks or hash marks, whatever that is for you, whichever one you prefer on your own. We use beakers if we need around a certain amount, but not an exact quantity. Okay, it's not for exact measurements. If I need around 100 milliliters, but it doesn't really matter if I'm more or less, then a beaker is fine. But if I need exactly 100, then it would be better to use a graduated cylinder. Now, for mass, mass is the amount of matter. And remember, matter is made up of atoms, so the amount of matter in an object. And remember, you have atoms, you're made up of atoms. So you're made up of matter. So you matter and are important. It's one of my favorite sayings in chemistry. Okay, so anyone who takes up space and is made up of atoms, has mass, they are important and they matter. And the unit that we use for mass in chemistry is going to be grams, and it uses the abbreviation of a lowercase g. So you'll see that on a scale. Now with mass, we use scales, like I just said, and if I draw two scales, which clearly I am an artist because these are very detailed drawings. If this is a scale, and on the scale I put some baking soda or something, and it reads 15.7 grams. But I put that same amount on a different scale, and it weighs 15.72 grams. The difference is not in the mass, but in the number of decimal places. So because this scale has more decimals, that means that it is going to be more precise than this first scale over here. So the more decimals a scale has, the more precise it is. Now remember, these both, they're called digital scales, but you also might see the word digital balances because we used to use triple beam balances. You probably used one in elementary or middle school, and we don't really use them very often in high school, definitely not in college, and definitely not in a research lab or in a business profession. So, first two types of measurement, volume and mass. The next two that we're going to talk about are length and temperature. Okay, so with temperature, the main thing that we want to talk about temperature is it measures how hot something is, but hot is not really an accurate science term. So when we're talking about temperature, it measures the amount of kinetic energy in atoms. Now, the reason why it's measuring kinetic energy in the atoms of whatever it's talking about is kinetic energy, if you remember from physical science, is the energy of movement. And so when things move fast, they get hot. And when things are moving slow, they are less hot because, fun fact, there's no such thing as cold or cold energy. It's a word that we use to describe when there is less heat around us and how we feel about that. But there's only heat. There's heat and less heat. And so temperature measures the amount of kinetic energy in the atom. So basically the speed of the atoms, how fast they're moving. And we use degrees Celsius in science. Now, in America, we measure temperature in Fahrenheit for weather and things like that. And this is not super great because only the USA, Myanmar, and Liberia use Fahrenheit and not the metric system. So it would be really great if the US could get back with, the rest of the world and stop trying to be so different, because that makes ordering tools, for example, if you're trying to order like a screwdriver or a wrench or things like that, and you order it from a company that's based somewhere other than the US, you're going to get one in the metric system, and it might not work on everything that you buy in the US. Now, for temperature, we use thermometers to measure this temperature, and they can be analog or non-digital thermometers where you've got the red liquid that kind of moves up and down in your thermometer, or you could have a digital thermometer, and they almost always have at least one number after the decimal. And depending on a digital thermometer, you might even get 2 or even 3 numbers after the decimal. So remember, more decimal numbers means more precise. Now, when we look at length, length is going to be the distance between 2 points. And when we measure length, we use, in science, again, with the metric system, we use meters. It has the abbreviation of a lowercase m. Now, you might see this with several prefixes in front of it. You might see centimeters, which is cm, lowercase c. You might see millimeters, which is lowercase m, or you might see kilometers or kilometers, which has a lowercase k and a lowercase m. Now, the prefixes all stand for something. So centi means 100, milli means 1,000, and kilo also means 1,000. But when we're talking about centi, we're talking about 100 small things fitting inside the meter, or 100 centimeters are inside 1 meter. When we talk about milli, we're talking about 1,000 small things, 1,000 millimeters fitting inside 1 meter. And a kilometer is actually the reverse. It's 1,000 meters inside one of these kilometers, because a kilometer is very big. And so when we are measuring length, it really depends on what instrument we're using as to how many decimals should be expected. So you really got to be able to pay attention to your ruler. For example, if I have a ruler and it's measuring in centimeters, and I just see 1, 2, 3, and the thing I'm measuring, let's use a yellow highlighter, goes from 0 all the way to there. Well, I know for sure that it's bigger than 1, but smaller than 2. So it's 1 point something, but I'm not really sure what should go after that decimal. Well, that is our estimated digit. Because it looks about halfway, I might say 1.5. But if I wrote instead, well, I think it's 1.6, that would be equally correct because that is our estimated digit and we do not know for sure. But we do have to estimate a digit because we know that it's not exactly 1. It is in between 1 and 2. That is what we know for sure. So this 6 is an estimated number or a guess. Now, if our ruler looks a little different, okay, if it still has the 1, 2, 3 centimeters, right, which clearly my scale is off. Let's try to fix that here, make them look a little more even. Okay, but in between we have 1, 2, 3, 4, 5, 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay, so if we have our meter stick and now the centimeters have those 10 tiny little millimeter marks in there, this will change how we measure. So if I have my yellow thing and now it goes to there, we can say, well, I know for sure that it's bigger than 1. And I also know for sure that it's higher than 1.5, but it's not quite touching 1.6. Well, then I could say if I left it at 1.5, that would be incorrect. Okay, because I know for certain 1.5 and I have to have an estimated digit. I could say 1.51, but because I think it might be close to 1.6, I'm going to say 1.59 centimeters. And so this 9 would be our estimated digit. Now, if you're on a multiple choice test, I'm sure that you're wondering, well, what if A says 1.59 centimeters and B says 1.58 centimeters? That would not be the case unless your teacher has said that there is more than one right answer. But most of the time, if I was writing a test question for this and asking you how long it was, I might put 1.59 centimeters. I might put 1.6 centimeters. I might just put 1.5 centimeters. And I might say, 1.5 1.592 centimeters. And we can go through what would be wrong in each. A would be our correct answer. 1.6 does not have an estimated digit. 1.5 centimeters also does not have an estimated digit, but 1.592 has two estimated digits, and you can only have one. And so that's kind of what's going on here with these rulers. So depending on the ruler and how small your graduations are, depends on how many decimals your answer should have.